Welcome to this daily LeetCoding challenge. In this question, we'll be finding if the array is comprised of valid subarrays. Given an array, we are going to partition it into contiguous subarrays. Contiguous means next to each other, touching. In the context of subarrays, this means we need to use all values. We can't skip or drop items from the array to keep only the valid subarrays. Every item must be part of the solution. The valid subarrays we are looking for are 2 matching items, 3 matching items, or 3 consecutively increasing elements, increasing by exactly 1. For example, the 3, 4, 5 subarray is valid. However, even though 1, 3, 5 is an increasing subarray, it is not increasing by 1. Therefore, 1, 3, 5 is not valid. Finally, take note of the constraints. Particularly that the minimum length of nums is 2. This will allow us to check for the first 2 elements before starting our loop, and we won't have to check the size of the array before accessing those elements. Like many problems that require building the final solution from smaller versions of the same problem, we can use dynamic programming. In this case, we'll be using an array with length 1 longer than nums and consider the empty array to be valid. This will allow us to build up our solution from the beginning of the array to the end. We'll use these brackets to indicate the range of the subarray we're checking to see if it's valid. Each step of the way, we'll be checking for matching pairs, matching triples, or consecutive increasing subarrays. We'll start at the beginning of the array. A single item will always be false because it doesn't meet any of our conditions. Moving on to the first 2 items, we only check for a matching pair. In this case, there is not a valid subarray. Now we're checking for all 3 conditions. In this case, we found a consecutively increasing section. Since the item prior to the subarray is valid, consider this as appending the valid subarray onto the empty array. This gives us a valid subarray. This is an interesting case. 6, 7, 8 is a consecutively increasing subarray. However, it would be appended onto 5, which is not valid, making the entire thing not valid. We need our subarray to be extending at least one other valid solution. Here we have a matching pair 8, 8. This is extending the array 5, 6, 7, which is valid. Therefore, this gives us a valid result. Here, the matching pair extends an invalid array 5, 6, 7, 8. However, the matching triple 8, 8, 8 is extending 5, 6, 7, which again is valid. This shows that we only need one valid path for a valid result. Overall, 5, 6, 7, 8, 8, 8 is considered valid. Finally, we have reached the last element, 7. This does not meet any of our conditions for a valid subarray. Our overall result for this array is false. Now let's take a look at the code for this solution. Here we have a Python solution. First, we initialize the DP array and check the first 2 elements for a matching pair. This will allow us to begin our loop at index 2, so we don't have to check the index before referencing previous values in nums or DP arrays. Once in the loop, we begin by checking for matching doubles. If we find a double, we can also check for triples. Note that we're using the OR equals operator for updating the DP array. This allows us to only require one valid path to consider the subarray valid. Finally, we check for consecutive increasing numbers. Having checked for all of our conditions after the loop, we return the final value in DP. This algorithm performs very well, beating over 90% of solutions. The space complexity is O of n due to the creation of the DP array, and time complexity is also O of n due to the for loop. Be sure to like this video if you found it helpful. And until next time, keep on coding on.